Dear students, in this video we are going to learn about the file system interface. In this file system interface, we are going to learn about various types of files and various operations performed on the files, to describe the interfaces to file system, to discuss file system design and directory structures. File is a collection of data spread in a contiguous logical address space. There are two types of files. One is a data file, another one is a program file. Data file contains the information in data in the form of numeric data, character data, binary data. Program is nothing but collection of instructions that may be having alphanumeric characters. Contents of the file is defined by the file creator. The files may be a text file, or it may be a source file, or it may be an executable file. There are various attributes are there for identifying a file. A file is identified by a name. This name is in the human readable form. Every file will be having an identifier. This is nothing but a unique tag used by the file system to identify the file in the system. Type is needed for systems that support different types of files. Location is nothing but pointer to a file location on the device. Size represents the size of the file. Protection represents the permissions that are given to different types of users, whether they have read, write, execute permissions or not. Every file will be having a time, date of creation and a user identification that represents who is the owner of that file, and also who are all the users that have accessed to that file, that is usage information. Many variations including extended file attributes such as file checksum is also maintained by some of the operating systems. Information is kept in the directory structure. So every directory will be having the list of its subdirectories and files maintained by it. This is one sample file information window on a Mac operating system. By seeing this window, we can identify the different information about the file, like it is a text document and it is created on so and so date and so and so time, and it is having what are the permissions, like here see who is the owner of the file. He is having read write permission. So staff is nothing but group members, they have read only permission, and others they have no access to this particular file. So likewise every file will be having its information stored in its directory. There are various operations that can be performed on the file. So as we know that file is an abstract data type. We can create a file by using the function called create. You can write the information data into the file by using the write function call. Read function call can be used to perform the read operation from the file. Seek is to reposition the file pointer within the file. Delete or truncate is used to remove a portion of the file. Delete is for deleting an entire file. Truncate is for truncating a portion of the file. A file can be opened by using the function open file pointer, such that it searches the directory structure on disk for entry F5 and move the contents of the entry to memory. Close is used to move the content of the entry F5 in memory to directory structure on the disk. These are the various operations that are commonly performed on the file. Open files. Several pieces of data are needed to manage open files. This open file table is used to keep track of the open files. A file pointer is maintained by the open file table. This file pointer is pointing to last read or write location within the file. This file pointer will be maintained for each process that has opened that file. File open count is used to represent how many number of processes have opened that file. Disk location of the file. It maintains the cache of data access information for that particular file. Access rights is nothing but per process access related information on that particular file. Access rights are nothing but it is like read permission, write permission, execute permissions to various processes within the system. A file can be opened in two modes. One is a shared mode and another one is an exclusive mode. When a file is opened in a shared mode, a file can be accessed by several number of processes at the same time. If a file is opened in an exclusive mode, then the file content is available only to the specific process, one single process. Example, a file is opened in a read mode. Read mode permits any number of files, any number of processes to open and access the contents of the file. That is, it is a shared mode. Exclusive mode is nothing but opening the file in write mode. When a file is opened in a write mode, that means we can perform write operation into the file. So when one process is writing the data into the file, the other processes are not permitted to access the content of the file. So therefore, write is an exclusive mode operation. Read is a shared mode operation. So any number of processes can open the file in read mode, whereas only one process is permitted to open the file in write mode. That is the difference. Various types of files are there. The type of the file is identified by seeing its extension. The extension may be exe.com or .bin or nothing. So the meaning of this is the file is ready to run machine language program. Some files will be having an extension .obj.o. That means it is a compiled file and it is in machine language and it is not linked file. So that is the meaning of .obj file. .c, .cc, .java, they are nothing but program files. .bat, .sh, that represents command interpreter. That means those files will be having the system commands that can be executed. .txt, .doc, it represents the document files. .wp, .tex, rtf, .doc, they are also word processing format files. They are also like a text files only. .lib, .a, .so, .dll, they are all library routine for the programmers. .px, PDF, JPJ, they are also a type of file only, viewed by different types of applications. .arc, .zip, .tar, they are nothing but compressed files. MPG, MOV, they are all like audio video files. So these are the different types of files that are available in the various operating systems. File structure. Generally, there are three types of file structures. The operating system can treat a file. A non-file structure means operating system treat the file as a sequence of words and bytes. So here, no specific format of the structure is mentioned. Just file is treated as a collection of words and bytes. Another variety of file structure is simple record structure. Here the file is treated as a collection of records. Each record is nothing but simple record structure. Simple record structure means the file is treated as a collection of lines. The number of lines may be fixed length or variable length. Next format of the file is complex structure. So here the file content will be in the formatted document, and it requires a relocatable load file to manage that particular file. We can simulate the last two with the first method by inserting appropriate control characters. Which type of file is to be maintained, that is decided based on the operating system and the programs. File access methods. The file access methods are two types. One is sequential access, another one is direct access. Sequential access means it is like accessing the contents of the file sequentially. That means if the file contains 10 records, we can access the records 1, 2, 3, 4 up to 10. Direct access is not possible. Suppose if the current file pointer position is here, you can go only forward direction. Suppose if you want to access the contents in the reverse, it is not possible. Only thing you can do is you can just rewind and go to the beginning position of the file, and again you can start accessing the contents from the beginning to end. So this is called sequential access file. So whereas direct access file, you can directly access the contents of the file any location by specifying the block number or record number. Just you say read n, that means it will read the nth record from the file. Write n means it will write at the nth record in the file. Position to n means you can reposition the current position, file pointer position to a specific record in the file. And you can also read the next record by using the read next statement. You can write into the next record by using the write next statement. Or you can rewrite the entire contents from nth location by using this rewrite statement. Like this, you can access any location within the file by using the appropriate statement in the direct access. Whereas in the sequential access, only read next, write next is possible. Otherwise, you can go to the beginning of the file by using the reset command. Another access method of the file is indexed memory access. In this indexed access, the file will have the index to the memory of that particular record. So each record in the file will be maintaining the address of the memory where that record is stored in the system. So therefore, if you want to access any particular record, no need to access them in sequentially. Directly you can take the address and directly you can access that from the memory. This is called indexed file. Here the disadvantage is if the number of records in the index file increases, again we need to traverse this file in the sequential order in order to locate the required record within the index file. So therefore, in that case we need to do is you can create an outer index table for the inner index table. In that way you can skip some portion of the index file for finding the required record in the indexed file. Directory structure. A directory is a container that is used to contain folders and files. It organizes files and folders in a hierarchical manner. A collection of nodes containing information about all the files. So directory is nothing but it is a container. It will have both folders and files. Folder is again nothing but another directory that will be having subdirectories. So each directory will be having subdirectories and files. Some directories may be having only files, some directories may be having subdirectories as well as files. Both the directory structure and their corresponding files will be residing on the disk. Operations that are performed on a file directory. You can search a file within the directory, you can create a file within the directory, you can delete a file from the directory, you can list the contents of the directory, you can rename a file, you can rename a directory, you can traverse the file system by using the directory hierarchy structure. Similarly, like you can search the directory, you can create a directory, you can delete a directory, you can rename a directory. All these operations are also possible on the directory. Why do we want to organize the directory? Means in order to have efficiently locating the file, we need to organize the directory. Convenient naming conventions can be used if you have a directory, because if more than one user want to keep the same name for the file, that is possible if you maintain multiple directories. And the grouping of various related files can be kept under the different directories so that it is possible to relate to them and find them in future in the appropriate time. Example, all the Java files programs are kept in a separate directory called as Java. All game files are kept in a separate directory called as games directory. Like that, you can have grouping of the files by creating an appropriate directory name. This is a single level directory structure. In the single level directory structure, we will be having the directories only at one level. The files are located under these directories. So subdirectories are not permitted in the single level directory. So the disadvantage with this single level directory is so many directories will be at the same level. Grouping is not will become a problem. For example, if I have Java files and another user also having Java files, I want to create a directory name called Java. Another user also want to create a file directory name called Java. Here name clash will come if both the users try to create a directory name Java in this single level directory structure. So therefore, this naming problem will occur in the single level directory. If I am creating like Java 1, the other user is creating like Java 2, then it is not a problem. But same name if you want to give, then it will become a problem. So if naming conventions are creating problem, then grouping of the files under the different directories will be a complex task. Two-level directory. Here two levels of directories are maintained. So this is under root. This is under the root. Multiple user directories are created. That means one directory for each user. Whereas in the single level directory, all the users will be having directories at the same level. Separate directories are not created for the users separately. Here, if he create a directory, it will be maintained in the single level directory. For each user, one separate directory is created. Under that directory, all the subdirectories are kept. Under the subdirectories, files are stored. So this is the two-level directory structure. You can access any file by specifying its appropriate path. For example, if X is a file, here to access this file, the path is user1/cat/x. In that way, we can use the path name to locate a file. So since multiple directories are there, we can have same name under these multiple directories for different users. Example, here test is one subdirectory created by user 1. Here test is another subdirectory created by user 3. This test is under the user 3 account. This test is under user 1 account. So therefore, there is no naming clashes. Similarly, the data under user 2, data under user 4 are treated differently. This makes efficient searching possible. No grouping capability tree structured directories. Here multiple directories arranged in at various levels. That forms a tree structure, and various levels of directories are created. Therefore, you will be having a flexible grouping of files here. That is the advantage compared to two-level directory structure. So, efficient searching, efficient grouping capability is possible. You can identify a specific file through its path. Another type of directories are acyclic directories. Acyclic graph directories allows a file can be shared by multiple directories. So let us examine. Here X is a file. It is a part of two subdirectories. That is, one is count under DICT. It is also a part of count under spell. So therefore, multiple directories will be having shared files. That forms some kind of acyclic nature in the tree. That's why it is called as acyclic graph directories. Sharing of one file by multiple directories is possible with the concept of aliasing. Aliasing is nothing but giving multiple logical names to a single file. For example, here X is a physical file available which will be having a logical link from two directories. So therefore, this logical link will be nothing but an aliasing name given to X, so that the file X can be accessed by its own name X or by using the aliasing name. So that is, it is like maintaining multiple names to the single file. The idea here is one physical file copy is available in the system, but multiple names or logical links are created to that particular physical file. The file will be deleted only when the last logical link is deleted. Until that, the file will be present in the disk. Until the last link is deleted, the file will not be deleted. The advantage of maintaining acyclic graph directory structure is sharing of files and directories is allowed between multiple users. Searching becomes too easy. Flexibility is increased as file sharing and editing access is there for multiple users. The disadvantage is because of complex structure, it is difficult to implement this directory structure. The user must be very cautious to edit or even deletion of the file, as the file is accessible by multiple users. If we need to delete the file, then we need to delete all the references of that file in order to delete it permanently. Then general graph structure. In general graph structure, cycles are allowed within a directory structure where multiple directories can be derived from more than one parent directory. Example, AVI is a directory. It is derived from two parents. One is from book present in AVI, another one is a book present under GIM. So likewise, multiple directories can be derived from more than one parent directories. The main problem with this kind of directory structure is it is difficult to calculate the total size or space that has been taken by the files and directories. That is a disadvantage. Thank you for watching this video.